Well, hey everybody. Good evening from Ellensburg. Standing right outside the window of the modem just to see if we have a nice clear stream by being outside. I'm afraid we're not set up to be outside again tonight. I'm still kind of experimenting with the modem, but guess I'm gonna hang here. Hey, all right, well, I've never met Randall Carlson, but I know of him. Hello, Lynn. You're a loyal person. Thank you for being with us tonight. So I'm kind of sitting in the... Kelly, you got your Cracker Jacks? That's good. That's wholesome. Very wholesome. Hey, everybody. It's wonderful to be with you. I'm going to just do a couple quick things with you outside here, and then we'll step inside like we did last night. Heard from a number of people of various ages. They can't seem to get notified when we go live, and then they forget. And so this is almost like when I tested things a few nights ago, but are you guys catching us right now because you just have a great memory? Or your phone dinged? Or did you set up your notifications to get an email? That's how I get notified of YouTube Live. You set an alarm, thank you. Phone ding, yeah, that notification from YouTube. I'm curious what the mode of the notification is, because I'd like to give folks advice about how to have YouTube notify them to remember to check in with us. I looked at the clock. I like that. All right, so yeah, as discussed earlier, notifications comes in different forms. Many of us just choose to turn all that stuff off. There's enough going on in our lives, but yeah, I tried telling about hitting the bell and all that sort of thing. Anyway, they can watch the replay if they kind of forget. And if you're with us and you had forgotten the last couple nights to join us live, welcome. So as you can see, we have another beautiful, calm evening in Ellensburg. I really would like to be outside, but I don't fear. I was really pleased with the quality of the stream last night, the earthquakes discussion. I didn't enjoy quite as much being inside, but I think that experiment worked, where we had the phone right next to the modem. Is that what it's called? And then I had no problems at all viewing on my end. The lighting was tough, Mark. I have a sheet hanging in the window now. We'll see if that works. Anyway, we just keep experimenting. Just before I leave this spot, I can literally reach out and touch the modem from outside. How's the streaming right now? I did notice when I started yesterday, just over there by the parking spot, I was just standing over there, basically by that red chair, and it was the same kind of choppy. So you're not getting choppy right now, are you? Because I think I think I just need to be within a few steps of the modem. Let me rephrase. Choppy or perfect? Those are your two choices. Excellent. Okay, great. All right. We got less than 10 minutes, so we need to get inside. Let's, hey! You wanted to come say hi? Did you want to say hi to these guys? Well, we were doing a lot of yard work today, weren't we? This is Bijou, and now Bijou's saying goodbye. All right. Oh, relax. No, I can't play with you right now. We got to go inside from walking away from the modem. Yeah, Bijou's on his own. All right. Feels like I know you by now. All right, well, we're back indoors. I moved the chalkboard a little bit closer. We'll see if the lighting is a little bit better tonight. And hello from Alaska. Hello from Ellensburg. Okay, so I'm going to be a lot of right in this range. And we'll have various lighting quality. How are we doing still with the stream? Choppy or clear? Looks good, Tom. Thank you. Hello from Florida. Clear, 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 clear. Wonderful. It's my pleasure to do these. I need something to do. We all need something to do. So I'll tell you what, before I forget. So tomorrow's Friday. I'm taking the day off. We're going to go hike over in a place called the Drumheller Channels. It takes a while to get over there. So we're looking, I'm tired of gardening, by the way, and doing all the yard work we've been doing. Had to thin out a bunch of the raspberries today. But anyway, I'll be back wanting to do this again Saturday and Sunday this weekend, 6 o'clock, both times. That's our normal time. And Ancient Rivers on Saturday, something called the Ellensburg Blue Agates. If you're not from Washington, you don't really know what that is, but I think it'll be interesting. And I hope to remember to do this right at the end when we sign off again tonight. All right, this is going away. Hey, we got 100 people already, is that true? Well, that's nice. So welcome. This is like the old Highlights magazine. What's different tonight? Did I just date myself? I think I did. There's a clock. I don't know if there's glare on the clock. I can't see through your comments. Anyway, we'll be doing a little bit of work with this. I'm just testing that out so I can kind of do that without it glaring too badly. This will work. Yeah, if I go too far, that's too, at least where the sun is right now. I'm facing west, by the way. When I watch a football game, for some reason, I want to know the orientation of the field. Most of them are north-south, but I want to know, am I looking east or west? I'm not even going to ask if anybody else thinks of that. I realize that's super strange. Oh, I got to check out I got to get the comments going here. Uh-oh, wait now. Oh, good. Got to mute the laptop, pop out the comments. This is what an old person does. Like narrate what you're doing. Oh, I've got the window open. So that's one more technical question for you. Are you hearing trucks? Are you hearing, I'm hoping you're hearing little bird chirps and other things that are pleasant, but this microphone in this little dinky phone is truly outstanding. And I'm curious if you're hearing anything that's kind of a distraction, especially if Muffler Boy goes by. No, audio's clear. You can hear a little bit, like right now. Truck went by, reasonable sounding truck. Is that big deal? Okay. Mm-hmm. All right, good. We'll keep the window open for a little bit. Hello, Lloyd. Thanks for joining us. Nancy and John. Bunch of names I recognize. That's kind of fun. And then, of course, folks from a long way away. Isn't this amazing to have this technology available to us? It really is something else. Okay, I'm going to go get a drink. Talked to my mom today. She said, why don't you drink something else? So that's what we'll do. H2O. We got 1 minute. I'm going to ask one more time. Stream okay? Liz is upstairs watching something on our TV using the internet. So, is the stream still okay? Hello, Brogan. That's great. Okay, we're about to get started. Good evening from Ellensburg, Washington, USA. Thank you for joining us today. Tonight we're talking about Ice Age floods. Ice Age floods. You've heard of the Ice Age, but Ice Age floods, that's something different. That's floods of water, cataclysmic, almost unbelievable volumes of water that are racing through the desert here in eastern Washington. And that really is kind of our aim today. So, for those of us here in Washington, especially Eastern Washington, I will be using some place names on occasion, but I know that many of you, most of you, are not in Eastern Washington and maybe have never been to the Pacific Northwest, so I'll keep you in mind and try to give you a sense of what's going on as well. Without being too kind of clubby about it. You know, it's kind of a bummer when people are talking about all these places you've never heard of and you're supposed to stay interested. So I'll try to make that work. Children, hello? Are you under the age of 10? What's your name? It's nice to meet you. My name's Nick. And I'm here at home and you're there at home and we're doing this together. Okay. So if you're new to us, here's the plan. I have a chalkboard here in the living room. I've got a couple of portable little whiteboards we're going to use. I've got a couple of maps I'd like to show you. And I have a program in mind, a very loose program that's going to take 15 minutes. Usually ends up being longer than that, but I'll try to keep it to about 15 minutes of me kind of lecturing about the Ice Age floods here in the Pacific Northwest. And then we'll open it up to your questions. I ask that you hold on your questions. Hold off on your questions until we're ready to do the Q&A. But yes, we've got comments streaming through here and I can see them happening, but I'm not reading them right now because I want to concentrate on giving you some good content. And then when it's time for some questions, I'll let you know. And I've got a laptop here and I'll kind of be able to scroll back and just kind of grab questions that I think might be helpful to answer. Okay, that's our plan. You know what? One more thing. If you enjoy what we're doing tonight, I'm going to take tomorrow off. That's Friday. But we'll be back at this Saturday and Sunday. I need something to do, and you probably want something to put on your calendar. So we'll talk about ancient rivers, especially here in the Pacific Northwest. On Saturday night at 6 o'clock Pacific time. Sunday we'll talk about the Ellensburg blue agates, a very local, prized possession for many, but I think there's universal appeal, and I'll bring some blue agates in and we'll look at them together. Okay, but you're here to talk about the Ice Age floods, and let's do it. This is a map of the Pacific Northwest. And I'm going to zoom in on the board now for just a second. And this is a map of the Pacific Northwest during the Ice Age. So here's the state of Washington and Oregon and Idaho and Montana. This is truly a Pacific Northwest story. And this white stuff here, can you guess what it is? It's during the Ice Age. Right, it's an ice sheet. It's a glacier that extends from here all the way to the North Pole, all the way to Santa's house. A huge ice sheet, and you're like, wow, I'd like to go see that. Well, it's not around anymore, at least on this map, but the ice sheet is still with us if you go to Greenland. A portion of North America where that ice sheet is still with us. It's retreating, but it's still with us during our short time on the planet. Okay, the star is Ellensburg, that's where my house is. And this is a key spot right down here in the state line between Washington and Oregon. It's called Wallula Gap. I'm not going to write it out. Wallula Gap. Keep that one in mind, okay? So this is an Ice Age story that so far doesn't sound very interesting. It's just a bunch of ice that's on the map and then the ice melts away. And that's true around the world. You have an ice sheet and then the ice sheet slowly melts away. And then the ice sheet comes back, it gets cold, the ice sheet goes away. This is a story of the Ice Age that's taking place over the last 2.6 million years. That's how much time we're talking about with an Ice Age. But over the last 2.6 million years, the ice sheets on planet Earth were constantly in flux. In other words, over the last 2.6 million years, we have lots of good evidence to say that global climate has been warming and cooling dozens of times. And so this ice sheet is constantly advancing and retreating. But this is the last advance and one of the most successful advances of the ice sheet. So we have no evidence that that ice sheet ever got to Ellensburg. We got no evidence that ice sheet ever got to Wallula Gap. But yet, Wallula Gap is part of our story. Why? There was a bunch of liquid water, not solid water, liquid water, floods of water. The topic tonight. There's Muffler Boy. That's going to come across this Pacific Northwest. So, can we do it quickly? I'm asking myself, can we do it quickly? I think we do. You want a flood of water? We need a source of water. The most obvious source of water is something called Glacial Lake Missoula. It was a lake during the Ice Age that no longer exists. Here's a more detailed map of Glacial Lake Missoula. This is a map put together by the Ice Age Floods Institute. You can get one of these for yourself if you go to iafi.org. And there's a little store where you can buy these if you want one shipped to you. So here's our ice sheet. This is just what I had on the chalkboard. Here is notice that the ice sheet, I even did this on the board. You see that the ice sheet has lobes to it, like earlobes. And it's this Purcell lobe in northern Idaho that acted as an ice dam. So in other words, all the rivers of western Montana were not allowed to flow to the ocean. Those rivers were blocked by this portion of the ice sheet in northern Idaho. If you know northern Idaho, Sand Point, the town of Sand Point or Lake Pend Oreille is a good place to go. Okay, that's where the ice sheet was sitting. Thousands of feet thick of ice, and all this water is ponding up behind it, Glacial Lake Missoula. Well, we're going to get an Ice Age flood by eventually having the water of Glacial Lake Missoula suddenly break through that ice dam. So there's lots of good field evidence to reconstruct where the ice dam was. There's lots of good field evidence today to prove where that lake used to be. There's old shorelines, there's stuff at the bottom of the old lake. So we're not dreaming it up. There's evidence for these two things. Eventually there's basically too much water in Glacial Lake Missoula and there's a flood, a catastrophic release of the flood. Let's have that water catastrophically released through northern Idaho, shall we? And we're going to have that Ice Age floodwater pick up a lot of speed. So this is water that was standing in Glacial Lake Missoula, but now it's let out of jail. It can move fast. It can move up to 40, even 50 miles an hour in places, and it's going to race. This water is going to race over eastern Washington. Common questions. How long did it take to drain the lake? There's been some work done on this with mathematics and the size of the deposits that are downstream, the size of the boulders, the size of the flood gravels, etc., and crunching the numbers to figure that out. A nice round number is to think of is 48 hours. 2 days, 48 hours to drain this immense lake and have that water race across eastern Washington. And you're like, oh, okay, so that's it? There was an Ice Age flood that took 2 days and the water got all the way to the Pacific Ocean in 2 days? Not quite. But what I've said so far is that we can think of about 48 hours to drain Glacial Lake Missoula. Now, this water's moving fast here. How do we know this was fast-moving water? And did everything get flooded in eastern Washington? Or are there just specific places? The answer is specific places. So, here's what eastern Washington looked like before the Ice Age floods. Before the Ice Age floods, we had a thick mantle of dirt. We call this loess. It's a German word, L-O-E-S-S. Loess is wind-blown silt. Have you been in your kitchen? Have you helped your parents make cookies using flour? Flour, kitchen flour. That's the consistency of this loess. And we still have thick piles of that loess soil in eastern Washington in places where the Ice Age floods missed. We call that the Palouse, and other rich agricultural places where there's dryland wheat. But underneath the loess, there's 50 feet of this stuff on average. Sometimes there's 250 feet of this loess. It's amazing. Beneath it is the German chocolate cake. Layers of basaltic lava rock that by nature are heavily fractured. This looks like I'm drawing limestone. If you're a geology fan, this is not limestone, this is basalt. And so there's amazing, almost crazy coincidence that the area that had all this thick flood basalt inundation 15 million years ago is the same place that gets hammered with this Ice Age floodwater. But what was the question? The question was, what happens when you have high-moving water coming through a bucolic scene like this? Is bucolic a word? I don't even know. The answer is, if you have one of these fast-moving streams of water, we call it a channel. Have you heard the phrase channeled scablands? That's the idea. The channeled scablands of eastern Washington. I'll show you a map in a second. But if you're in a place that got hit by erosive Ice Age floodwater, a huge canyon is formed. So the loess is gone, and that's easy to visualize, but hundreds and hundreds of vertical feet of very heavy lava rock, bedrock, is also picked up and moved by the floods. That's the stunner. And this canyon, this valley that has a very specific shape, very vertical walls and very flat floors, is the main way to tell where an Ice Age flood happened. It's called a coulee. So you may have heard of the Grand Coulee, or Frenchman Coulee, or Potholes Coulee. There's many, many others as well in eastern Washington. Those coulees were created during the Ice Age floods. The coulees are the result of Ice Age flood erosion. So my very quick yellow arrows here are basically showing you where the coulees are located. Shall we go back to the professional looking map? Still don't like this lighting, whatever. Basically blinded, I can't even see my own thing now. Do you see these dark areas? These dark areas are where the coulees are located, oftentimes. Now out here by Ritzville, between Spokane and Ritzville, if you've driven the freeway, I-90 between Ritzville and Spokane, you lose much of the agriculture, especially if you're driving east and you leave Ritzville and you drop into this kind of barren area. It's barren because all the loess is gone. There's not a giant coulee here, however. So sometimes the loess is just stripped away, but the underlying bedrock remains. But there are rare places like the Grand Coulee where we not only take the loess away, but the Ice Age floods are concentrated, they dig, and they create one hell of a canyon. The Grand Coulee, Moses Coulee, other coulees as well. Okay, I got to pick up the pace here. It's already 1:15. Remember we mentioned Wallula Gap as part of this story. So Wallula Gap is a narrow eastern gateway to the Columbia River Gorge. So Portland, Oregon is down here. The Columbia River is flowing through Wallula Gap, and the Columbia River is the way for these Ice Age floods to get to the ocean. But Wallula Gap is such a narrow entrance to that gorge that our fast-moving floodwater is going to stop. It's literally going to stop. It's not going to slow down. It's going to stop. We're going to put the brakes on that water. And we're going to make another lake. This lake is called Lake Lewis. It's not technically a glacial lake. It's not a lake impounded by ice. It's a lake impounded by the narrowness of Wallula Gap. So this water in Lake Lewis is basically the water that's waiting its turn to thread through Wallula Gap and then finally get to the Pacific Ocean. Lake Lewis is important because imagine what you are, say it differently. Our fast water, remember we're picking up all the loess? Think of all that loess then going into water. It's almost like Nestle Quick. You know Nestle Quick, the brown powder, and then you stir it up, super unhealthy, whatever, tons of sugar. But you make chocolate milk by taking vanilla, by taking regular milk, and then stirring a bunch of chocolate powder in. These Ice Age floods were brown. The soil was put into the water, and so if we think of brown water now in Lake Lewis, with each passing day, with this steady, still water of Lake Lewis, with each passing day, that soil is going to start dropping to the bottom of Lake Lewis. And with each passing day, Lake Lewis water gets clearer and clearer. That's important because when we finally do drain the rest of the water through Wallula Gap and through the Columbia River Gorge, there was a bunch of that soil that got dropped at the bottom of Lake Lewis. Are you still with me? The soil was thick here. The soil was picked up by the fast water. When the water got stopped, that soil was redeposited in something we call a slackwater sediment layer, or a tushy bed, or a rhythmite. They all mean the same thing. They're chalky white layers, and each chalky white layer is interpreted as a separate Ice Age flood. So in just a second, we're going to talk that there was actually more than one flood. And one way to realize there was more than one flood is to count each of those slackwater sediment layers. Basically, to count each of those layers at the bottom of Lake Lewis. That's why Lake Lewis is a big part of this story. Finally, the water drains to the ocean, and if you're really taking all the water, which was in Glacial Lake Missoula, and get all that water to the ocean, maybe it's 2 weeks. Maybe it's 2 weeks by the time we get all that water to drain through Wallula Gap and get it out to the ocean. That's one Ice Age flood event. Now I want to focus on a couple other key parts of this story, and then we'll open it up to questions, okay? There's, of course, many subtleties in this story. And one of the subtleties is, when you have a lot of fast water coming down an area, let's pick the biggest and best example. Let's pick Grand Coulee itself. Grand Coulee itself is basically a huge canyon formed kind of out in the middle of nowhere. Like, why was that the spot that made the biggest of all the coulees? And the answer is, there was another part of this ice sheet. There's the Purcell lobe that was the ice dam that broke every once in a while. Here's the Okanagan lobe, another part of this ice sheet that was sitting there. And so notice there's another glacial lake. This is Glacial Lake Columbia, basically where the Columbia River is trying to flow, but we've got another big part of the ice sheet blocking the way. Here's the upshot. We're getting sophisticated now. Glacial Lake Missoula bust through the ice dam. There's a Glacial Lake Columbia right downstream of Spokane. So all this water is going to dump into Glacial Lake Columbia. And we're going to overfill this bathtub and have water spill over the southern margin of that clawfoot bathtub called Glacial Lake Columbia. So instead of water just racing like crazy over eastern Washington, like I just kind of told you on the chalkboard, instead, it's kind of a daisy chain. Standing water, break through, dump into another glacial lake, standing water, have the water go fast. Then have Wallula Gap hold the water up again, then drain all the water. My point now is that we're going to have a waterfall. We're going to have water spilling out of Glacial Lake Columbia and spilling right down this pathway that we now know as Grand Coulee. Originally, where the waterfall was located was down at a place called Soap Lake. The original waterfall in the Grand Coulee area was at Soap Lake. Let's draw that. Here comes fast-moving water down the area that we now know as Grand Coulee. Crappy marker. It's a sunny day in the Ice Age. We're going to have the water spilling over this lip and hammering this area here, and we're going to make a plunge pool or a place where we're actually just digging into the bedrock. So this is a waterfall that everybody loves. Everybody loves waterfalls. Honeymooners love waterfalls. Niagara Falls comes to mind, but this is much different than Niagara Falls. This is oftentimes more than 200 feet of water, a column of water 200 feet thick, moving 50 miles an hour over a cliff that's 250 feet tall. That's not Niagara Falls. This is not a passive river falling over. This is an immense flood of water. Glacial Lake Columbia spilling over and coming down what is now known as the Grand Coulee. But here's what I want to demonstrate to you. If we have that much water cruising over this cliff doesn't stand a chance. I'm going to lick my fingers now. I'll wash my hands, I promise, after the lecture, okay? I've been sequestered for like 4 days. I shouldn't do it, okay. There's erosive power of this water coming over the cliff. The cliff is going to be eroded back. It's that cracked basalt we were talking about. So after the flood is done, we just caused the lip of the waterfall to move, maybe a half mile, maybe a mile. I'm not exaggerating. We don't really know, so maybe I'm exaggerating. But we're migrating the lip of this waterfall to the north. Another flood. Move the lip of the falls back. Another flood. You got it? We're going to migrate this place where the waterfall was. So the original waterfall was at a place called Soap Lake. But as we migrate the lip of the waterfall north, we're going to lengthen something called Grand Coulee. And today this is where Dry Falls is located. Dry Falls. That's what some of you were thinking about when I was mentioning that. Okay, I got a few more things to say, and then I think I'm opening up to questions. I've talked to many different groups about these Ice Age floods over the years. I can kind of anticipate the questions we'll have, so let me do a couple without even looking at yours, okay? I hope you don't mind. How many floods were there? If there was definitely more than one, How many were there? We don't know. We have to keep this story connected to the field evidence that we have. That's a major, major message. Everybody loves telling stories. And it's okay to be creative with your ideas. But your ideas have to be based on the field evidence that we have. Let me give you a couple of quick examples of how we know that there was more than one flood. We could ignore the Slackwater sediments in Lake Lewis if you want. There's a place called Moses Coulee. And Moses Coulee brings up a lot of questions that are difficult to answer. Son of a gun, I'm moving this. We're not doing this in this living room again. Sorry. Moses Coulee is right here. At the mouth of Moses Coulee, where Moses Coulee dumps into the Columbia River, there are 5 batches of basaltic gravels that clearly were a big flood that came down Moses Coulee and dumped a bunch of basaltic gravel where the water spread out at the mouth of Moses Coulee. So there's one coulee where we have at least 5 big floods that came down that little stretch. While we're here, why does that coulee just disappear under the ice? Is it possible there's a different source of water than Glacial Lake Missoula? For sure, Glacial Lake Missoula is the source for many floods. We can get into that evidence if you like. But if you talk to Canadian geologists and a few open-minded Washington geologists, there are arguments that a bunch of meltwater was coming out from underneath the ice sheet. Think tunnels of water underneath a melting glacier and sending water directly from Canada as opposed to water from Montana. This doesn't have to be either or. This could be some floods from Montana, some floods from British Columbia, some floods from another source as well. Let me finish with this with my little program, and then I'll go anywhere you want to go. Do we have any feeling of dates on this? Yes. There's 2 ways we have dates so far. Do you remember our Slackwater sediments? So if you interpret, and most now do, each Slackwater sediment as a separate Ice Age flood, whether it's from British Columbia or Montana, it doesn't matter, it's a flood, and we got water stopping at Wallula Gap, there's at least one layer where there's some very fine and well-developed volcanic ash that's from Mount St. Helens more than 16,000 years ago. And so we know from that date that some of the Ice Age floods were a little bit younger than 16,000 calendar years ago, and many were a little bit older than 16,000 years ago. But in other words, we can't get ages from the Slackwater sediments. It's just kitchen flour. It doesn't have anything in it to help us keep track of time. But we can sample a volcanic ash, figure out the ash came from Mount St. Helens, and using the chemistry in the ash, figure out the age of the ash. There's a new technique that some of you have heard about called surface exposure dating. By the way, what happens when you have an ice dam and you break it and we release the water? The answer is there's going to be broken pieces of the ice dam that are in the flood. And especially when that water stops at Lake Lewis, we're going to have icebergs. And oftentimes, here's a rock. Stupid idea. Oftentimes, you got boulders that are actually riding on the iceberg. What's the evidence for that? We have boulders that clearly traveled more than 100 miles by the Ice Age floods. Some of them tumbled along the base of the floods, but quite often, boulders being carried by the icebergs that are at the top of Lake Lewis, and those icebergs get perched on a hillside, the iceberg melts away after the Ice Age flood, and the boulder is left. What's the surface exposure technique? It's a new technique in the last 10 years or so. The dating technique is this. You sample the surface of the boulder. You basically break off carefully an upper slab of the boulder, and you send it to a lab, and you measure parent and daughter isotopes in that slab that were created, the daughter isotopes were created by bombardment of cosmic rays. Cosmic rays striking that surface, and basically chemistry happening in this lab to keep track of time. And if you're like, that sounds like science fiction, I have no faith in that whatsoever, I'm kind of with you initially until you start seeing the results. And I know the people doing the work, I value their work. They're careful, meticulous people. And many of their specific boulders, where they've calculated they've measured how many years that boulder's been sitting there exposed to cosmic rays after the Ice Age flood left. Those numbers are also in the range of 24,000 years ago until about 13,000 calendar years ago. So if you've been waiting patiently, this is a new story to you, you're waiting patiently for when this actually happened, and God forbid, is this going to happen again? Like everything else seems to be happening in our future. No, we don't have any ice nearby. We don't have to worry about this at all, kids. But this story of dozens of Ice Age floods, we have the best evidence for dozens of Ice Age floods between 22,000 years ago, maybe 24,000 years ago, and about 13,000 years ago. There's more detail coming in, but not enough time for us to lay that out today. And I can't hold it. There's also some evidence for some Ice Age floods that were hundreds of thousands of years old. Hundreds of thousands of years ago, we had ice and Ice Age floods in the area as well. So, this is a rich topic. It captures so many people's imagination. And therefore, people never get tired, it seems, of talking about it. And for good reason, especially if you know these areas. Okay, 6:30, right on the dot. Hot damn. We're going to do Q&A. I've got my laptop right here. If you're new to us, I would ask that you put your caps lock on when you ask a question, please. And it will be easier for me to see. And I'll try to answer as many as I can. I probably won't get to your question, but I'll try my best to just get as many of these going as I can. I'm going to scroll back and get off of live for a second. Lake Bonneville, breakthrough at Red Rock Pass, considered an Ice Age flood. Absolutely. So we were talking about the Ice Age floods related to Glacial Lake, Missoula, and perhaps some Ice Age floods crossing the border from Canada underneath the ice sheet. About this time, roughly 18,000 years ago, there was one flood that came from Utah. Utah's off the map here, but Utah's down here. I'm not even sure you can see this. So Lake Bonneville was a bunch of lake water during the Ice Age time sitting above Salt Lake City where they had the earthquake yesterday. And there's a place called Red Rock Pass just to the south of Pocatello, Idaho, where I went to graduate school. And so there was one big Ice Age flood called the Bonneville flood where we drained much of Lake Bonneville over Red Rock Pass. That Bonneville flood followed the Snake River. Followed the Snake River into Hell's Canyon. And then that Bonneville flood also got stopped at Wallula Gap. So, Bonneville flood is definitely part of the story. Separate source of water, only one flood, no icebergs. But petrified watermelons. Long story. Is the start of each lake a sign of falls moving north? Park Lake, Blue Lake, Lenore Lake. Oh, I see. So the question is, within the Grand Coulee itself, there are little lakes. And do they line up with each time we jump? Or maybe is each lake a plunge pool? I never thought about that before. I don't think so, but I'm not sure of the answer. I don't think we can tie those existing lakes to old plunge pools, but it's a really creative thought. If that's what you meant, I've never had that question before. Good job. Good job by you. what animal fossils are found in these flood deposits along with plant fossils? Okay, now this is, hold on to your hats now. The Slackwater sediments, there's a bunch of sediments at the bottom of Glacial Lake Missoula. There's no fossils. There's no fossils. There's no plant fossils. There's no animal fossils. There's nothing to get to sample that has carbon in it to get an age. It's spooky. And the conventional thought is, well, it's really cold, kind of ice age water that's only there for a short amount of time. And I'm no biologist, but that's frustrating that we've got really nothing in those lake sediments to help us with dating or just trying to reconstruct the scene at all. Thanks for the question. Do you find basalt layers downstream? I'll interpret your question the way I think I hear it. What happened to all the lava? We have tons and tons and tons of lava that are being hauled out of these coulees. Is all of that rock being sent all the way to the Pacific Ocean? Most of it, no. If you think of a big rock column, you know rock columns out in eastern Washington, that's basalt. And if you think of those columns being plucked away from their neighbors, like big Ticonderoga pencils that are being pulled away and hauled off by the water, those columns are going to shatter. They're going to break into, if they're Tootsie Rolls, they're individual little segments of the Tootsie Roll. And even those segments get broken into smaller and smaller pieces. But to me, the main thing to realize is that we're not keeping the speed up. If we kept this, let's say 60-mile-an-hour water, if we kept that speed all the way to the ocean, I think everything would be out in the ocean. But there are plenty of places, not only in Lake Lewis, but even places where the Ice Age floods are coming around a corner or being deflected by a ridge. Saddle Mountains comes to mind, Drumheller Channels comes to mind. And we're dropping a bunch of sediment any place that the water slows down a little bit. So we don't really go to the Pacific Ocean for the most part to find sediment, but that would be helpful. There's been a little bit of work done on this, not much, to go out. Obviously it's inconvenient. We got a lot of marine water in the way. But if we can go out, there's huge fans of material out here that were flushed by the Ice Age floods, presumably. And maybe there's some detail out there that can help us answer some of our questions. I'm going to keep scrolling around here. Hi Patrick, 6 years old. I don't see your probably. Did the Puget Sound area experience any sort of Ice Age flood phenomenon during all this? I know Seattle was covered with ice. Yeah, there's a smaller Ice Age flood story in Puget Lowland. First of all, Ellensburg, where I live, missed the whole thing. We got no Ice Age floods that got into this valley. 30 miles to the east of us is Vantage, and that's prime Ice Age flood erosion country, but the ridge between us and Vantage, Ryegrass, Summit, saved us from the Ice Age flood devastation. And I can say that casually, but the oldest archaeological sites we now have in the Pacific Northwest and the youngest Ice Age flood deposits we have in the Pacific Northwest are overlapping. And what I'm saying is we're starting to realize that people were living here during some of these Ice Age floods. And you can fill in the rest of the story. We don't need to go there, but this is not millions of years ago. This is a time when Native Americans who knew the land like better than anybody, and even have stories of some of these events. This is a real thing. We're overlapping. I forget. Oh no, Seattle. So Seattle was under 3 miles of ice. Downtown Seattle was under 3 miles of ice. I'm not making that up. 3 miles. And where did all that water go when that ice finally melted? Some of it went in the form of an Ice Age flood down the Chehalis River. Basically crossed the divide down by the Black Hills and Chehalis and then got out to Aberdeen and Hoquiam. I don't know the details of that area very well. But J. Harlan Bretz, I think we'll do one of these just on Bretz, did some amazing work a century ago in that area. So it's not a crazy question. Ice Age floods are part of that area as well. Not nearly as dramatic as out here in eastern Washington, though. Are there any other places on Earth with similar flood stories? Yes. My knowledge goes way down, but Ice Age floods in other places in North America. We have Glacial Lake Agassiz flooding. We have the St. Lawrence Seaway with some stories there. Asia and Europe, big Ice Age floods coming through portions of Russia. English Channel somehow tied to this. I should know more and I don't. I apologize. But, you know, it's kind of American to say, you know, we're the only place on the earth that's got this, or this is the best example in the world and the longest lava flow in the world. I'm not into that sort of thing. Mostly because we just don't know. We don't know. I mean that literally. Like, there's other wonderful places that have been studied very carefully, and you just don't know the details of those places. But I've met a few Ice Age flood geologists from other continents, and they've done work similarly there. And I did my best to follow what they were saying. Yeah, I covered that, Lloyd, briefly. Difference between rhythmites and varves. Yeah, I might as well share this with you. So, at the beginning of this month, a guy named Tom Foster passed away suddenly, and I really miss him. He was only 60 years old, and Tom and I, for about a decade, made a bunch of Ice Age floods videos. And the last one that we made was on Glacial Lake, Missoula. And what I really wanted to do in that episode was go to some of the deposits in the bottom of Glacial Lake, Missoula that are right along Interstate 90. And Tom was so gifted with still photography and also the little video camera we had. I was able to show the difference between varves and rhythmites. Because I feel like it's confusing for people. Even in geology, people are mixing up the terms. Classically, varves are interpreted as annual deposits. You have a dark and a light layer of mud, essentially, clay. Dark, light, dark, light. And the dark represents winter, and the light represents summer. This is seen in modern lakes today. So if you're looking at varves, you're on a tiny scale, like in that Glacial Lake, Missoula. You can just Google or put into YouTube search box Glacial Lake, Missoula. You'll probably find this 15-minute video that we did a few years ago. Rhythmites are these major, thick, chalky white layers that we were talking about in Lake Lewis, but there's also slackwater sediments or rhythmites in other places that the water slowed down. Glacial Lake Columbia. Other places that look like it's the same story, but it's very difficult to correlate between those slackwater sediments worldwide. Let's keep it going. How does the type of rock/earth in the flow path impact how the flood progresses? Example, if Washington was more craton than terrain plus flood basalt, would things have gone differently? These are all excellent questions. I won't keep saying that. Here's what I typically teach. If the bedrock of eastern Washington was granite, I don't think we'd have much record of the Ice Age floods. Because granite is not heavily fractured typically. Oh, let's pick something even more quartzite. Can we make quartzite the dominant bedrock of all of eastern Washington? It's not, but let's have it be that. Those Ice Age floods would just skim right over the surface. Even if we had loess and get that away, I really don't think the water would be able to dig in and carve coulees if it was quartzite. And to me, that's one reason that when you get up into the Okanagan area, which is out of the flood basalts, and many U.S. geologists say, I don't see any evidence for Ice Age flooding coming down the Okanagan. I think part of that is there aren't any flood basalts up there. We don't see our classic erosional features like coulees and big deep potholes. We don't see a bunch of flood gravels. It's just a different bedrock type. So I do think the basalt is a key part of helping us kind of preserve where these ice age floods were so erosive. Is it too involved to say a bit about J. Harlan Brett's? You know what? That reminds me. So this is an experiment. We got 15 minutes left. You're gonna come with me now. I'll be back to your questions in a second. I'm just curious, first of all, if the stream is still good out here in the front porch. But so it's a beautiful evening. And this is where I do a lot of my work. And I brought this old map from 1961. It's an old map that somebody was using in our department, and this is how they used to put these maps. So let me get this up here. Sorry about that. I don't know if this is going to work or not. Are you still there? And can you hear me? Okay. Shit. You still there? Sorry, I swore. Oh no, I'm locked. Hang on. Oh no. Oh no. Oh my God, are you still with us? I don't want to hit that X. I don't want to kill this feed, but this orientation thing is all screwed up. All right. Oh. You're still back. Okay, great. So this is not what I had in mind, but I'll try it like this. I'm kind of standing on my head now. I sure wish I knew what I was doing at the moment. All right. This is an experiment. That's what this is. So this is Ellensburg. This is Vantage. This is the Grand Coulee. There's a motorcycle. And what I want to show you, I'm not even going to, oh yeah, okay. So this is a map that was published in 1961. And I hope that you can see where the channels are. And where this yellow is where we still have the kitchen flower, where we have the loess. My main point is this map was made in 1961, and it ignores J. Harlan Brett's work. If we go carefully to the Spokane area, they have ice over Spokane and down this far. That's what Brett's first thought in the early 1920s. But then realized this was a whole Ice Age flood story and there was never ice over Spokane. And my point in kind of showing that even in the early 1960s, this is about the time that I was born, nobody was teaching about J. Harlan Brett's. Nobody was teaching that this was an Ice Age flood story. Even though based on what we just said tonight, isn't it obvious that these are channels of water? The story back then is that the Columbia River was diverted, which we still believe, and the Columbia River was just swollen a little bit to carve the Grand Coulee. And the fact that there was this immense amount of water traveling so fast and carving all these landscapes in the order of days instead of millions of years was sacrilege. Okay. I'm feeling like I'm on borrowed time now, so I want to go back, get us back to where we are, and get to a few more of your questions before we quit today. Thanks for being willing to play along. Do we have evidence for Ice Age floods when the continents were not in their current position? No. We have evidence for older ice ages where, when Pangea was together, for instance, we had an ice sheet covering much of Pangea. That was between 300 and 200 million years ago. But if there, interesting question, if there were Ice Age floods at that time, we don't have evidence for those. That evidence is long gone. So ice evidence, yes, from earlier times, but the scale of this Ice Age flooding that we're talking about worldwide is confined to the last 2.6 million years. Please forgive me if I'm not getting to your question, especially if you're a younger person and you've been asking your question patiently. I'm sorry that I can't get to them all. I hope I get your question in the next few minutes here. Was Palouse Falls created by the Ice Age floods? Yes. So there's one of these channels. So we're back to our Glacial Lake Missoula story, dumping into Glacial Lake Columbia, this bathtub overflowing, and here's a straight shot. It's called the Cheney Palouse Track. And water was spilling directly to Pasco, where Tom Foster used to live. And the Palouse Falls area has a river today. That's just the Palouse River. And I would guess that most people that visit Palouse Falls, even today, without reading an interpretive sign, would think, well, the Palouse River is really powerful to make this big canyon. But the Ice Age floods came through there and did most of the digging. And the Palouse River actually came in after the digging was done and kind of took advantage of all that heavy lifting by the Ice Age floods. How does the volume of Lake Missoula compared to the Great Lakes? I never have crunched the numbers on that. I should have, and I don't. I don't typically compare it to the Great Lakes because 19-year-olds here in Washington don't know Lake Michigan. I should have an answer, and I don't. I'm embarrassed to say. I'm sorry. Have you checked out the 12 new Ice Age Flood Institute brochures? Yes. In terms of today's Great Lakes, yeah, I'm going to get away from the Great Lakes, if you don't mind. Major Tom to ground control. Are we out, or am I just missing some things now? I'm just skipping through and looking at the uppercase. Let me go back and see if I can find a few more before we quit. We got 8 minutes left. Like, I don't know why I'm so tied to that. I'm scrolling back now. Oh, this is when I turned my phone off when we were in the front porch. Could you help us? Could you tell us about colks, please? A little bit, yeah. There's these amazing... So if we're trying to compile evidence that the Ice Age flood was so powerful, are we really sure that's true? Well, it's very difficult to explain the size of the coulees. It's also so difficult to explain a hole out in the middle of nowhere called a pothole that's 50 feet deep and 50 feet across. Like you can put a pickup in the bottom of these things. They have to be drilled by water, and the water is typically, I don't know the fluid hydraulics of it, but there's places at the base of dry falls, let's say, there's other places where the water gets concentrated and swirls in these eddies like underwater tornadoes, and they have this kind of sucking ability, don't go there, sucking ability to pull the bedrock up and out and carry it away. I'm weak on the math with that, but that's the conventional exploration there. Are those big erratics on the Waterville Plateau from flooding or dropped by glaciers? Yeah, this is I didn't know this 20 years ago when I started driving up on the Waterville Plateau. The sun has set, so we don't have quite the glare that we had before. That's upside down. Underneath where this ice was sitting is now a very unique part of eastern Washington. It's called the Waterville Plateau. It's near Dry Falls, but you climb up out of Grand Coulee Highway 2 crosses the Waterville Plateau, and north of Highway 2 especially, if you Google Mansfield, there's some amazing haystack rocks, they're called. They're super big milk duds sitting there. And they look like they're boulders that were brought in by the water, just like some of these other big boulders. But the difference is many of those boulders are in a place where there's glacial till. And glacial till tells us that the ice sheet deposited those rocks instead of water. So the haystack erratics, the haystack boulders on Waterville Plateau, brought by the Canadian ice sheet and carried just a couple of miles, because not very far north of the Waterville Plateau is the Columbia River. And once you get north of the Columbia River and get into the Okanagan and up by Nispelem, you run out of the basalt. So the basalt was picked up by the ice sheet, carried maybe 5 miles, and then dropped. Yeah. I'm still freelancing, scrolling around with my uppercase here. You're still with us. That says a lot about you. I like you. Now I'm kind of revisiting my old turf here. I do coulees have straight vertical walls and flat floors. That's the fracture pattern in those basalt lavas. That basalt is pre-cut and ready to be hauled off by the floods. So it's not like the waters are etching out those vertical and horizontals. Those are the orientations of the fractures when the lava cooled millions of years before the Ice Age flood. Phoenix, age 9, wants to know how far the lava rocks got. When the lava flows were flowing, now this is way before the Ice Age time. This is a flood basalt story going back 17 million years. But some of the lavas came out of my hand and flowed all the way to the Oregon coast. And so much of this area here of the Pacific Northwest was buried in more than a mile of lava. Thank you for the question, Phoenix. Yeah, well, why not? Comet impact, Younger Dryas hypothesis, 12,000 years question mark. We'll finish with this. I love that so many people are talking and thinking about geology now. That really is not the case 10 years ago, 15 years ago. There's been an explosion in interest, and it's wonderful to see. There's a relatively new set of ideas tying Ice Age floods in North America to an impact by a comet. It's called the Younger Dryas event. 12,800 years ago, I believe, is the date used. For the area I'm talking about here tonight, that date is too young for the surface exposure dates of the boulders. It's too young for the Slackwater sediment dates that we have, even though there's just a few. As I understand the Younger Dryas, there's no field evidence in the Pacific Northwest that talks about flooding that young. The youngest documented from the work that I'm familiar with here in the Pacific Northwest, the youngest event is a little in the neighborhood of 13,300 calendar years ago. That's too young for 12,800 years ago. So I'm all for creative thoughts. I'm all for involving as many people as possible. But I don't see the field evidence here in the Pacific Northwest with the dating information that we have to tie to that as a source of some of the flooding or all of the flooding. Was there just one flood? That's ridiculous to say there was one flood. Come out to Eastern Washington, we'll show you all this evidence for multiple floods. That's an easy one if you go out and look at the field evidence. But the Younger Dryas and the 12,800 or whatever that date is, younger than 13, I don't see it. working with the data that we have today. So, for those that want to continue with these, I don't know if you're watching them live. Well, you are obviously watching them live, but if you're catching these after the fact, I'm taking tomorrow off. My wife and I are hiking in the Drumheller Channels, a place where the Ice Age floods did their thing. It's a beautiful area, this time of year especially. So I don't want to be worried about getting back by 6 o'clock. We're going to spend the whole day over there. The flowers should be out, the whole thing. But you are certainly welcome to come back. 6 o'clock is our normal time here, Pacific time. You know how to find us now. Nick Zentner's YouTube channel. And I'll be streaming live Saturday night and Sunday night at 6 o'clock. Talk about ancient rivers. And on Sunday, talking about the Ellensburg blue agates. Thank you for joining us tonight. I sure hope that everything's going well where you are. Things are going well here. We're all doing what we can to get through this. Till Saturday night. Good night from Ellensburg, Washington. I love you.